Hi everyone, in this video all I want to do is briefly introduce collisions, which is a major component of the momentum chapter. I'm just going to talk about the two types of collisions there are. But the first thing I just want to say is that regardless of the type of collision that we're going to deal with in the momentum chapter, the key point to all collisions is that momentum will always be conserved. So just to write something down here, momentum is conserved during a collision. Which means if you're going to analyze a collision and do the physics behind it, you can always start your math or your mathematical analysis with the conservation of momentum, which is the initial momentum equals the final momentum. Start with this. Now there's two types of collisions that we'll be seeing. One is inelastic. And in an inelastic collision, objects stick together when the collision occurs. So for instance, if we have two cars, let's see here, there we go. There's car A, and it's rolling along, and car B is at a stop sign. And car A runs into car B, and they stick together, and they move off as one. So we do A here again, and B kind of gets stuck right here. They move off together. That would be an example of an inelastic collision, where there are two objects and then they get stuck together and they move off as one. And just to give you an idea of the type of math that we'll be doing, we'll only do this for inelastic collisions. Let's imagine that car A had a mass of 100 kilograms and had a velocity of 4 meters per second, and car B also had a mass of 100 kilograms. What would their velocity be when they move off after the collision? So velocity after the collision, I'll call it velocity AB. Well, the initial momentum is just the momentum of object A, which is 100 times 4, or 400. Object B has no momentum to start because it's at rest. So my initial momentum is 400. That means that my final momentum must also be 400 due to the conservation of momentum. So if I want to find out what the final velocity is, momentum equals mass times velocity. Velocity is the momentum divided by the mass. 400 divided by, now the mass is the mass of everything that's moving, the system mass, so that's 200. And I would get a velocity of the coupled objects to be only 2 meters per second. Which kind of makes sense because we have an object that was moving at 4, it ran into something, and now you have these two things that are heavier, so the velocity has to go down to conserve momentum. And we'll do some examples of that as we go through the chapter, but that's an example of an inelastic collision. With an elastic collision, the objects don't stick together, they bounce off of one another. So objects bounce off one another. An example of that would be like if you're playing pool and you have one ball and it's moving along and it strikes another ball. It's a darker ball, and the one ball stays in place and the darker ball moves along. This would be an example of an elastic collision. Still in this, the initial momentum will equal the final momentum. They're going to be equal to one another because momentum is conserved. If they're the exact same mass, it makes it really easy. All the momentum transfers, and the object that was moving in at, let's say 2 meters per second, the one that leaves will leave at 2 meters per second. So just a really, really quick overview of collisions. The key points are that momentum is conserved in a collision, and we have two types: inelastic, where the objects stick together, and elastic, where they bounce off of